So the following examples are application problems we'll be doing with our order of operations. So let's read the story problem first. Air pollution can be reduced by riding a bicycle rather than driving a car. Define the number of pounds of pollutants created by starting a typical car 10 times and driving 50 miles. Find the value of the expression, the quantity 52.84 times 10 plus the quantity 5.955 times 50, all divided by 454. So what's nice about this is though we're given all this information in the story problem, the story problem is just asking us to work with this expression that we have. And so we're going to do the order of operations. So let's follow the top first. And so I look inside the parentheses, 52.84 times 10. So when I'm multiplying by 10, all I do is move the decimal place over 1 point to the right. So 52.84 times 10 is 528.4. Now I'm going to use my reliable calculator to do 5.955 times 50. And I get 297.75. So 297.75. And that's still all over my fraction of 454. So same idea. I can't do my division until I combine my numerators together. So we're going to take our 528.4 and add it to the number we found, which was 297.75. And I get 826.15. And then I'm going to divide that by 454. So 826.15. I'm going to divide that answer by 454. Now if I look 1.8197, let's round to 2 decimal places. So then that will make this value 1.82. And so then that is our answer. The following application problem has us looking at geometry. And so here we can see we are asked to find the area of a trapezoid when our height is 6, one of our bases is 22, and the other base is 17. So I have here our trapezoid formula. You take your height, divide by 2, and then multiply by the sum of your two bases. So same idea. We're going to take in to find the area. It's just like working with a variable expression. We're going to plug in what we know. H is 6, B1 is 22, and B2 is 17. So order of operations says work inside your parentheses first, your grouping symbols first. So 22 and 17 is 39. And then I work outside. I can see I have 6 divided by 2, which is 3. So then my area is 3 times 39. And so 3 times 39 is 117. So it was as simple as just plugging in the values that we know and performing the order of operations from there. The following application problem deals with our simple interest formula, which says that your interest, I, is equal to your principal times rate times time in years. Now this example, you do need to be careful with our units that we'll be using. And the reason why is because your time has to be in years. And if we look at the example we're given, our time is in months. So then we're going to have to convert this month, 36 months, to years. And we have to be careful with one other thing, and we'll get to that during the problem. So let's plug in what we know. We want to find our interest. So our interest is equal to our principal, P. So that'd be 1,500. And we would do times our rate. And I'll skip that and go right to our years right now, time in years. Well, 36 months, is going to be equal to 3 years. So then I'm going to plug in for my t, my time, 3, not 36. So always be careful with units when you're dealing with formulas. And the reason why I skipped over my rate is for the same reason, is when you're dealing with percents, yes, it's 6.5%, but when you're doing calculations with percentages, you need to remember to convert your percent to a decimal. So 6.5% is actually 0.065. And so we're going to do the same thing before. This type of thing, follow order of operations. We're going to, since it's all multiplication, multiply straight across with our problem. And if you were to type this in your calculator to do 1500 times 0.065 times 3, now your calculator says 292.5. Again, we always need to be careful with story problems with our units. I mean, you don't go to a grocery store or go to a store and buy something and the register never says, hey, $292.5. Whenever you're dealing with dollars and cents, but you always have to round to 2 decimal places because that's where our cents are. So though your calculator says 292.5, we know when it comes to money, there's 2 places after the decimal. So don't just follow what your calculator says. Be careful with following our units. Now an application problem deals with gas mileage. Skimming over the story problem, I'm going to use one color and underline all the important variables that we have and formulas for this one. The longer the story problem, the more, I would say, filler words there are, and we need to make sure our minds and our eyes focus on the important parts. So I'm told here Rick has D dollars, so I have the variable D for dollars. Now the formula for the number of gallons of gasoline that Rick can buy with D dollars is given by G equals D over 3. So it looks like G is going to be our gallons. And the formula for the number of miles that Rick can drive on G gallons is M equals 21G. So M for miles. The question asks us, how many miles can Rick drive on $8 worth of gasoline? So I'm trying to find how many miles. So I'm trying to find M. I'm given $8, so I'm given D. So I want to find M, and our problem tells us M equals 21G, but I'm not given G, I'm given D. So we have to figure out how can we use our dollars to get gallons. And that's where our first equation comes in. Our first equation says G equals D over 3. So if I plug in my 8, G equals 8 over 3. So now I know my variable G, and so I can plug that right in to M equals 21G. M equals 21 times 8/3. And if you do 21 times 8/3, you are going to get 56. So therefore, Rick can get 56 miles on $8 worth of gasoline.